Hi everyone, it's Snyder time. Today's lesson we're going to be finding limits both graphically and numerically in calculus. Since we're at the very beginning of our calculus course, we should discuss the two major reasons that we need calculus. The first reason is the tangent line problem, which asks, how do we find an equation of a line tangent to a curve at any given point? Our second reason is the area problem, which asks, how do we find the area under a curve? In order to deal with either of these situations, we need to be able to work with limits. So to start, I'd like you to do a quick warm-up and find the area of a square with side length equal to 4. As we know, area of a square is equal to side squared. If our side length is equal to 4, area is equal to 4 squared. So our area is equal to 16 units squared. In order to relate this to limits, we're going to take this one step farther. I'm going to ask you to fill in the table and find the area of the square if s is close to 4. Take a minute, pause the video, and come back when your table is filled in. Now that your table is filled in, this is what it should look like. You should see that as s gets closer and closer to 4, our function value, area, is getting closer and closer to 16. This is true coming from both the left and the right side of 4. This is reflective of a limit. Here's our informal definition of limit. It states if the values of a function, f of x, approach the value L as x approaches c, then f has limit L as x approaches c. Basically, what this is saying is if we're approaching an x value from both the left and the right, what is the function value or the y value as we get closer and closer to that x? So here's our limit notation. The limit as x approaches c of our function f of x is equal to L. So for our previous example, we would write the limit as s approaches 4 of our function s squared is equal to 16. We're now going to do one example problem, finding limits numerically, just like we did in the warm-up.